What's up guys, and welcome to this video tutorial. This is a concept video and we will be going over momentum, impulse and kinetic energy. Okay, all of these three topics are related. So let's get into it. So the first thing that we're going to touch on is momentum. Okay, so to understand momentum we first need a definition. Okay, so the definition of momentum is the product of the mass and velocity of an object. Okay, so that's all momentum is. Momentum is just the product of the mass and the velocity of an object. Okay, and the equation, let's do it in green. The symbol that we use for momentum is P, and it's equal to the mass times the velocity. That means it has units of kilograms meters per second. Okay, and it is a, remember, if we multiply a vector and a scalar, it results in a vector. So momentum is a vector. Okay, then we need to go over kinetic energy. So kinetic energy, or EK. Okay, so what is kinetic energy? Kinetic energy is the energy an object has as a result of the object's motion. Okay, so I'm hoping that most people are familiar to this, to what kinetic energy is, and we also call it EK. Okay, so the symbol for kinetic energy is EK, and it's equal to a half mass times velocity squared, and it has units of joules. Okay, and energy is always a scalar. Okay. Okay, so let's just work with these two equations very quickly by doing a quick example. Let's pick a nice color for examples. Let's do them in purple. Okay, so let's say we have a car with a mass of 2,000 kilograms, has a velocity of 5 meters per second. Okay, first we want to find momentum and find the kinetic energy. Okay, so if we start off with the momentum, we can say that P equals m times v, which is quite simple. The mass is 2,000 and the velocity is given as 5 meters per second. So our momentum is equal to 10,000 units of kilograms meters per second. Okay, that would be our answer. And then if we want the EK, or kinetic energy, is equal to a half mass times the velocity squared, which is a half times 2,000 times our velocity, which is 5 squared. And if we plug this into our calculator, we get a value of 25,000 units of joules. Okay, so like I said, just an easy, quick solution to try and understand these two concepts. Okay, so momentum on its own, we often don't just calculate the momentum, but we're looking for something else. So let's think of a situation where, let's say we have a object, let's say a ball that is hit into a wall. Okay, so what we care about there is not the momentum, but rather the change in momentum. Okay, so that's the next concept that we go into. Okay, so how the momentum changes. Okay, so let's say we have a car that goes into a wall, right? That's the situation. So we've got a stationary wall here, and we have a car that drives into the wall. Okay, so we know that according to Newton's third law, the wall will simultaneously exert an equal but opposite force onto or on the car. Okay, but so there's two situations that can occur, right? When we think of a car that goes into a wall, either it's very unlikely that the wall stops the car completely. Either the car will rebound off of the wall, or the car will actually go through the wall, right? So therefore, there must be an unbalanced force. So if the force is unbalanced, or if we have an unbalanced force, if the force is unbalanced, it will cause the car or the object to accelerate. Let's just call this the object to make it a bit more generic. Okay, so the object will change. So basically, it will either accelerate backwards or it will decelerate forwards, slowing it down but making it move a little bit. Okay, so that's a very important concept, and that gives us the equation of change in momentum. So change in momentum is going to obviously equal our momentum final minus our momentum initial, which is equal to our mass times our velocity final minus our mass times our velocity initial, which we say is a u, which is equal to mass times velocity final minus velocity initial. And that gives us a change in momentum, which has the same units as, it's got the same units of momentum, obviously, which is kilograms meters per second. Okay, but this right here is quite an important equation. So let's just go into a quick example once again on using change in momentum. It's quite simple, but okay, so example 2, let's say we drop a 500-gram ball. Okay, the ball strikes the ground. With a velocity of 10 meters per second and leaves and rebounds with a velocity of 6 meters per second. Okay, so and then we want to calculate delta P, or the change in momentum. Okay, so if we had to draw out the situation very quickly, so we have a ball, right, and we have the ground. Okay, so the velocity initial is equal to 10, and then the ball hits the ground, so at some point hits the ground, and then at some point afterwards it rebounds with a velocity of 6 meters per second. Okay, important is to note the direction of these arrows, okay, because that will play quite an important role. So when we want to actually calculate the momentum, our change in momentum is equal to our mass, our final velocity minus our initial velocity. Okay, now the question is, what direction do we take as positive? So we can pick, let's take downwards as being the positive direction. Then we have 500 grams, which is 0.5 kilograms. Our velocity initial is going to be a positive number, but our velocity final is going to be a negative number because it's in the opposite direction. So what we actually have is 0.5 times 16, which comes out at 8 kilograms meters per second. So that was what our change in momentum is. Okay. I actually have done that in the wrong order. Our final velocity, sorry about this, our final velocity is actually like that. So if we take downwards as positive, our final velocity is minus 6 minus our initial velocity is 10 minus 16, which is minus 8 kilograms meters per second. So that minus sign indicates that it's away from the ground. The momentum is away from the ground. Okay, and the reason that I was able to pick that up is because I saw that the change of momentum was positive. That means that it should be going towards the ground, not away from the ground, which is what I was expecting. So be very careful with these signs, because you can easily make a mistake just like I did. Okay, but yeah, that's basically what I wanted to cover in this video. So we've gone through 3 concepts: momentum, kinetic energy, and change in momentum, and we've done a couple examples. Hopefully you were able to pick up that mistake before I did. And yeah, so this is the end of this video. In the next video we will do elastic and inelastic collisions before we go on to impulse. So thanks for watching, guys. I hope you found this useful.